So welcome to the another video of data structures using Java playlist. In this video, we will be looking at selection sort. We will be dividing this video in two parts. First of all, we will check the working of selection sort, and then we will see the implementation part about the selection sort. In previous video, we discussed about bubble sort. Just in case if you haven't watched that video, do go and watch the video. Now, the selection sort is a bit different as compared to bubble sort. In bubble sort, what we used to do is we used to compare two adjacent elements, and if these two adjacent elements are not placed in the correct order, we simply used to swap them, right? But what does exactly selection sort says that it contains an array which is divided into two categories. So it simply assumes that my array is categorized into two parts. Let's suppose this is my total array and it's divided into two categories. First category is considered as a sorted part, and then second is considered as an unsorted part. And basically what we do is we simply pick the smallest element from the unsorted part and we place it at the first position, or simply we can say that to its correct position. So this is how exactly the selection sort mainly works. Now let's try to have the dry run of selection sort over the given array. Now as we discussed that we basically divide our array into two categories. First one is called as a sorted part and second one is called as unsorted part. So what I will do is I will simply assume this part as sorted part, which is nothing is sorted as of now, and this will consider as unsorted part. Now what I will do is I will simply assume, let's suppose my array is 1, 4, 2, 5 and 3. Now I will pick this element, and what I will do is I will simply assume this is my minimum element. I will simply assume it. Now what we discuss, we will go to the remaining elements to the right of it and find the smallest element. Now which is the smallest element to the right of this 4? 1, and simply we will bring that 1 to its correct position. So it will be 1, 4, 2, 5 and 3. Now see, our array is divided into two categories. This is sorted part and this is unsorted part. Now what I will do is I will assume this 4 as my minimum element, and I will try to get the minimum element which is smaller than 4 to the right of it. So 2 is a minimum element which is smaller than 4. So simply I will bring that 2 into its correct position, that is 1, 2, 4, 5 and 3. Now if you see that my array is again sorted part and unsorted part. Now what I will do is I will pick this 4 and I will try to get the minimum element to the right of it which is less than 4, which is nothing but 3. So again I will simply bring the 3 to its correct position. So it would be 5 and this would be 4. Now again this is sorted part and unsorted part. Now what I will do is I will pick 5 and try to get the minimum element to the right of 5 which is less than 5, which is nothing but 4. So 1, 2, 3, 4 and 5. So this is how exactly the selection sort mainly works. Simply what we are doing is we are picking one element, that is 5 element, and for the remaining n minus 1 element we are finding the minimum element which is less than the 4. Then we move on to the second pass. We compared the second element, right? Second element, and for the remaining element we found this minimum element which is less than my 4, and that I simply swapped with 4. Again I went to the third pass and I picked that third element as the smallest element and tried to get the minimum element which is less than this 4, and again I simply swapped it to its correct position. So simply what exactly we are doing here is we are running a loop, that is outer loop, for I equals to 0, I is less than n minus 1 and I plus plus. Now again the question comes, why I am running a loop n minus 1 time? Because if you observe carefully that here total size of n is 5, and how many operations or how many passes I have performed. So here I have performed first pass, second pass, third pass, fourth pass. But if you observe carefully that the total elements are 5, but I perform only 4 passes because these first 4 elements came to its correct position. So the remaining one element will be automatically present at its correct position. This is what exactly we saw in the bubble sort also. That is the reason why I don't need to look for all n elements. I simply need to check for n minus 1 element, because the nth element will automatically present in its correct position, right? So I hope so you got why we are running a loop for n minus 1 time. Now every time what we used to do it, every time we used to assume that my first element is my minimum element. In first pass the second element is my minimum element. In third pass my third element is my minimum element. So every time we used to assume the element where my I is present is my minimum element. So let's suppose I have the minimum index which is nothing but I. And now what I will do is I go on checking the smallest element to the right of that element, which is less than this 4, which is less than this 4. So it will go from I plus 1 till it will go till n j plus plus, and it will simply compare if my a of j, right, a of j is less than a of minimum index. Minimum index is nothing but the index of the smallest element. If it is, I will simply update my minimum index to j. And now once I come out of this loop, what we did is we simply swap that minimum element to its I, right? Here I equals to 0, we simply swap it with I equals to 0. Here I equal to 1, so simply I swap that minimum element to ith position. So simply I need to swap that minimum element with a of I. It is a of I comma a of minimum index, right? So this is how exactly the selection sort mainly works. What we are doing is we are simply going on checking the minimum element and place it into its correct position, then find the second minimum element, place in its correct position, then find the third minimum element, place into its correct position. In this way we try to find n minus 1 number of minimum elements so that nth element will automatically get placed to its correct position. Now what will be the total time complexity? Again outer loop is running for n times, inner loop is also running for n time, because let's suppose the value of I equals to 0. So j will move from 1 till n. So approximately it is running for n times. So total time complexity would be big of n into en. So I hope so you understood the implementation and the working of selection sort. Now let's move on to IDE and try to code it out. So what I did is I simply took one array whose size is 7. Now what we told is outer loop will go on till n minus 1 time. So simply I will run a loop from I equals to 0, I is less than size minus 1 and I plus plus. And what I will do is I will simply get the index. Which index? Minimum index, which is currently I. Now I will go on checking the element to the right of it which is less than the current minimum index element, right? So what I will do is if my air of j is less than air of minimum index, then simply I need to update my minimum index at j. And once I come out of this loop, I am going to simply swap that element with I. So temp is equal to a of I, right? In a of I, it will contain as a of minimum index, and in air of minimum index, it will contain as temp. So this is how our code looks like. Now let's try to print the code so that we can check whether my array is completely sorted or not. So simply I will run from 0 to size and I plus plus, and go on printing each and every single element of array. Okay, now let's try to run this code. See, my array automatically gets sorted. So 1, 2, 5, 10, 22, 33 and 90. So this is how exactly the selection sort basically works. Again, the outer loop runs for n times, inner loop runs for n times, so overall time complexity would be big of n square. Swapping will take place in big of 1 time, so we won't be considering this. So just in case, if you like the way I am teaching you, do subscribe to the channel for more such informative videos so that you can master data structures using Java.